Alright, so this is Stat 200 Lesson 1. So first, cases and variables. So a case is an experimental unit from which data are collected. Typically, cases are people. And a variable is a characteristic that is measured and can take on different values, something that can vary. There's two different types of variables we're going to discuss, quantitative and categorical, but for more on that later. So an example, a third grade teacher wants to know if students who spend more time studying at home get higher homework and exam grades. So here in this example, the third grade students are the cases because each data that is collected varies based on each student, so that's the case, and the variables are the homework and the exam grades. So the two different types of variables I mentioned, categorical and quantitative. So a categorical variable is a name or a label, like a category with either a logical order or no logical order. So they're basically qualitative variables. That's how they differ from quantitative variables, which are numerical values that can be placed in a meaningful order with consistent intervals, so they're numerical. Quantitative can be either discrete, which is a set value, or continuous, when it has a value between values, which is commonly decimals. So here's an example. You can just determine if these variables that I show here are categorical and quantitative, and describe if they are discrete or continuous as well. So take a moment, pause, and we'll go over it in one moment. All right, so first starting out, weight. Weight is a quantitative variable. It doesn't specify here, but it is continuous because you can have a value in between a certain value. So you could have, you could be 160.56 pounds. Favorite ice cream flavor is categorical. It's qualitative. It fits in a certain category. There's no numbers associated with ice cream flavors. Highway mile markers, these are quantitative. They are also continuous because they have values in between values as well, just like weight. Similar, running distance is similar to highway mile markers in that it is quantitative and continuous. There can be values in between values, so 8.4 miles ran, which is a long way to run. I would not ever run that far. Finally, children per household. It is sorry, why does it say categorical? That is quantitative. That is quantitative. And it is discrete because you cannot have 1.5 children per household. You cannot have 3.4 children per household. You can have 1, 2, 3, or 0. All right, so next. Explanatory and response variables. Let me erase these real quick. All right. So an explanatory variable, also known as an independent variable, it explains variations in the response variable in an experimental study. So on the counter, a response variable, also known as a dependent variable, is the outcome that is measured. So it's very important to note that response variables are measured following a manipulation of the explanatory variable. So, example, how does the hours spent studying affect one's exam grade? The hours spent studying would be the explanatory variable because they can be manipulated. And then the exam grade is what you're measuring. Someone may argue that you measure the hours spent studying. No, you assign someone to measure, you assign someone to study a certain number of hours, and then you measure their results based on how long they studied in their exam grade. So next is samples and populations. One of the main goals of statistics is to gather information from the population to make inferences about the population. We call that inferential statistics. But it's very hard to gather information from the entire population. Could you imagine gathering data from every single person in the world? It's very hard. So in order to make general inferences about the population, you gather information from a smaller subset of the population, which is called a sample. We call these statistics. So a statistic is a measure concerning a sample. A parameter is a measure concerning a population. So whenever we make conclusions, we want to make conclusions in terms of parameters because we want to make conclusions about the population. We don't want to make conclusions about a sample because although that does hopefully reflect the population, we want to ultimately make a conclusion about a population. And inferential statistics, I already mentioned that we use data from samples to make inferences about the population as a whole. So here's a review question. A survey is carried out at Penn State Altoona to estimate the proportion of all undergrad students living at home during the current term. Of the 3,838 undergrad students enrolled at the campus, a random sample of 100 was surveyed. So identify the sample and the population here. Take a moment, pause. I'll go over that in a few seconds. So here in this problem, the 3,838 undergrad students represent the population because we want to know the proportion of undergraduate students at Penn State Altoona. We don't want to know the proportion of undergraduate students in universities across the country. We want to know specifically Penn State Altoona. So to know that that is the population, we take all the students from that campus, which is 3,838. The sample here is, I know it says random sample, but you want to make sure that you know a little bit more about that because not always will you be given the fact that it says that it is a random sample. Of the population, a certain subset was surveyed, so 100 students, hopefully that represent the population as a whole. They are the sample here in this case. So next is sampling bias. A representative sample is what we hope for, a subset of the population from which data are collected that accurately reflects the population. In cases that aren't representative or can lead to unrepresentative samples, there's bias present. Bias is a systematic favoring of certain outcomes, so sampling bias favoring certain outcomes due to the method that you take to obtain the sample. So sometimes the way that we use to find cases or to find data that we collect is not always random and is not representative of the population that we're trying to make inferences about. So here's an example for you. A medical research center is testing a new weight loss treatment. They advertise on a social media site that they are looking for volunteers to participate. Is there a sample bias present? Is this a representative sample? Take a few seconds, answer that question. I'll go over it in a few seconds, explain why yes or no. All right, so yes, there is a sampling bias present. No, this is not a representative sample. Typically, if there is a sampling bias present, it will not be a representative sample because you do not want to have sampling bias. They do not represent the population as a whole. So in this case, the keyword here that we identify that shows us that there is a sampling bias is that they use a social media site to look for volunteers. So this is not a way to get to the population. Only a certain subset of the population uses social media. So typically, not all senior citizens use social media, so they may be having a bias there. It is not representative of the whole population. So you want to keep that in mind. All right. So next, sampling methods. So first is simple random sampling, which is a method of obtaining a sample from a population in which every member of the population has an equal chance of being selected. So before, as we were talking about the social media bias, if you're only advertising on social media, not every single person in the population has an equal chance of being selected because, as we all know, hopefully not everybody in the world has social media. So another type of sampling is convenience sampling, which can also lead to sample bias. It's a method of obtaining sample from a population by ease of accessibility. So this is not random, this is not representative. This is making it very convenient and easy for the for the researchers to find samples and to collect data. That is very easy for them. That doesn't provide much travel cost, things like that. So it makes it very easy, but again, it may not be representative of the population as a whole, and it's most likely not random. So sampling methods. So non-response bias and response bias are two different types. So non-response bias is favoring of certain outcomes that occurs when the individuals who choose to participate in the study differ from the individuals who choose not to participate. So for me, the best way I understand this is with extreme cases. So extremely positive or extremely negative. Something driving someone to participate in a study or something driving someone not to participate. Sometimes people in the middle choose not to participate for a reason that differs from the people who choose to participate very, very largely. And response bias is varying of certain outcomes that occurs when participants do not respond truthfully. This may align with social norms or to appease the researcher. So I went through an example of this. If your teacher tells you that they want to take a survey of how long their students studied for the final exam, and they ask the students in class to tell them how long they studied for the final, they may change their actual answer. They may say, oh, well, I studied for 10 hours for the final, but they actually studied for 1 hour. That changes the data because they want to appease the researcher in this case, but they want to please their teacher and not make it seem like they didn't study for the final. All right, so here's a review question. You can decide if this is response or non-response. A restaurant invited their recent customers to complete an online survey. Customers who had really strong feelings about their experience, either positive or negative, were likely to complete the survey, while customers who had neutral experience were much less likely to complete the survey. So is there non-response or response bias present here, or none at all? You can decide. Take a moment to decide. All right, so here non-response bias is present. This is a very relatable example, at least for me. I know that people who are more motivated by bad service, too high of a cost, bad food at a restaurant will be very likely to participate in a survey to hopefully make their future experience better or to make the experience better for the restaurant's future customers. Or if somebody had a great experience, had a great server, had just a great experience at the restaurant, will want to tell the restaurant how great it was, that they don't want them to change, that they want to keep certain things so that they can experience it more in the future. That is a non-response bias. But someone who said, oh yeah, it was normal time at a restaurant, they most likely not respond to a survey because they don't think there's anything that needs to improve or with the restaurant. So that is where the non-response bias is present here. So experimental and observational studies. So these can be confused easily, but there are a few points in each definition that you'll want to take note of. So experimental study is a study in which the researcher manipulates the treatments received by the subjects. This is also known as a scientific study. But here you want to note that they're manipulated. that is probably the biggest difference between an experimental study and, oops, that is not pretty, an experimental study and an observational study. You'll definitely want to note that the subjects are manipulated, they are changed, they do something that they wouldn't normally do necessarily, but in an observational study, the researcher collects data without any manipulations at all, so everything is left to nature. It is the subjects are in control of their what they do. It's also known as a non-experimental study. So sometimes the problem with observational studies is that they don't take confounding variables into account, which are variables that differ between cases, and they're related to both the explanatory and response. Sometimes you'll also hear them found as confounding, third, or lurking variables. But for instance, in an observational study, some researchers might ask subjects perhaps experience on a medication, and they did not manipulate them, so they're just asking for their experience, but they may not take that subject's prior medical history into account when researching them, so that could be a confounding variable there. Yeah. So some key terms here: randomization, causation, association. Randomization randomly assigns cases to different levels of the explanatory variable. So this is very good. This is very good for any study that's happening, any research study. Random treatments. Randomization makes the results more effective and accurate. Causations mean that a change in one variable can be attributed to changes in a second variable, and it is semi-related to association in that there is a relationship between two variables. So here's a review question: do 6-month-old babies who are being breastfed weigh more than a 6-month-old baby who are not being breastfed? Data were collected concerning 10,000 6-month-old babies. Whether or not the baby was being breastfed was recorded, as well as the baby's weight in pounds. Which of the following statements is true about this study? So pause it, and I'll go over the answer next. All right, so A is true here. The study does lack randomization. B is not true because their replication we do not go over in this class. C, the group that is being breastfed is the placebo group. There's no placebo group here. It's just an observational study. That's why D is incorrect. It is an observational study. There's no randomization in this study because we're just taking accounts of people's of the weight of babies who are being breastfed and babies who are not being breastfed. There's no randomization that needs to occur because there's no treatments here. So next is independent and paired samples. Independent groups are cases in each group that are unrelated to one another. So the changes in one group do not affect the change in another group, for example. So here's an example for independent groups. A t-shirt company is studying how many t-shirts American men and women own. In one research study, they take a random sample of 1,000 American adults and ask each individual if they identify as a man or woman and how many t-shirts they own. Pair groups, cases in each group are in some way matched with one another. So an instructor wants to compare student scores in the midterm and final. She obtains a sample of students and records each student midterm exam score and final exam score. So here with paired, you want to take note that they're comparing the midterm and the final exam score with each student, so that's how they're paired. And independent, the fact that there is a woman does not affect how many teachers they own, and the fact that they are a man does not affect how many teachers they own in the study as an entirety. the cases are unrelated to another. So, control groups, placebos, and blinding. A control group is an experimental condition that does not receive actual treatment. So, they may receive a placebo or they may receive nothing at all. A placebo is something that appears to the participants to be a treatment, but it doesn't contain the active treatment. So that is where randomization occurs. Sometimes they assign placebo randomly, and that makes it better for the patients. So there's more accuracy in reporting. Blinding is used to avoid bias, which is very useful. There's two different types of blinding: single blind and double blind. Single blind is when the participants don't know the treatment they had been assigned to, but the researchers know. Again, double blind is when neither the participants nor the researchers know which case is assigned to each treatment. So that makes it for total blindness. The participants can't blame the researchers for anything or ask them what they're receiving because they have no idea what they're receiving anyways. So review. Oh, already went over this review. Sorry. All right, so that's all. Next review session is next Sunday. And if you have any questions, please type them in the chat box. If you haven't entered your PSU ID, please go ahead and do that now. Thank you all for coming.